Today we are building an inverter from a few past projects. Good day everyone and welcome to my channel. Let's go through the parts quickly. We have a regulator, which is a 7805 regulator I made in a past video. We have a computer fan that has been modified to output a frequency to drive MOSFETs, also made in a past video. We have two IRF Z44 MOSFETs already mounted to a heatsink, two little transistors, some resistors, and a transformer that has been center tapped. This transformer is a 24 volt AC transformer that I split the windings in the middle to get a dual 12 volt output. This is perfect to use for an inverter. Let's get started. For now we are just going to move the fan and the regulator out the way, and then we are going to grab the MOSFETs with the heatsink, and we're just going to bend the pins of the MOSFETs. This is just going to make it easier to solder later on. A little trick I learned, but you don't have to, but it does make it much easier. You can go ahead and bend the gates of the MOSFETs as well. I find keeping all of these low voltage components like the gates and the sensitive electronics that go along with it, keeping all those far away from the drain of the MOSFET generally helps, and it also helps a little bit just to keep everything neater and make soldering much easier later on. Now that that's done, let's go ahead and grab our first pair of resistors. These are 10 kilo ohm resistors that we are just going to solder across the gate and the source of each MOSFET. This will just drain the voltage out of the gate of the MOSFET when it's done switching, because if the MOSFET stays on when the other one switches on, you'll basically cause a very big short and the circuit will go bang. Believe me, I know, I found out the hard way. You can see that I just wrapped the resistor around the source and the gate. This is just going to make it easier to solder so it doesn't move around, especially if you're doing it with one hand and your other hand you're holding your soldering iron and trying to hold your solder and trying to film. It gets a little complicated. So I just wrap it around the source and the gate. Just when I solder, it just stays there without moving. Just like that. You're going to leave those legs of the two resistors quite long, because that will help to keep all the other parts together and solder them onto something. Let's go ahead and solder that up quickly. There we go, that's one MOSFET done. Just a little bit more, there we go. Next one. And now let's quickly do the gate of the other MOSFET. There we are, just like that. Apologies to all my viewers who are busy watching this video at this point. My camera decided to not focus on this section, so the next few seconds of this video is going to be a little bit blurry until I discover that I have to refocus it. My sincere apologies everybody. But you're not missing anything. Right now I'm just busy putting the two sources of the MOSFETs together via those two long cables or legs of the resistors that I said you should leave. Makes things easier. Again, apologies for the very blurry picture. Let's move on to the transistors. These transistors are both C3198 transistors. You can see I'm just bending the legs a little bit. Also just going to make it more convenient to solder later. Again, apologies for the blurry picture. Right now I'm just busy soldering a little bit of a blob onto the gate. Just trimming off the excess. Doing the same with the opposite MOSFET. There we go. Now we are going to solder the emitter of that MOSFET, sorry, the emitter of that transistor, my apologies, to the gate of the MOSFET. And there we go, my camera's back in focus. Sorry about that, my viewers. Again, we're going to do exactly the same with the other MOSFET. We're going to take the emitter of the transistor and solder it to the gate of the MOSFET. These two transistors are there to help regulate the power and also provide a nice smooth switching for the MOSFETs. As if you do not switch them properly, they will act like very big resistors. They will heat up very quickly and shortly after go bang and release magic smoke, which is not a good thing. Now that that's all soldered up, just bend it a little bit straight. There we go, just like that. As you can see, they are both soldered, emitter to the gates of the MOSFETs. Now we're just going to grab some red cable. This cable we will solder onto the collectors of both transistors. Off camera, I'm just busy prepping the wire to make it easier to mount and solder onto the transistors. I'm not hiding anything, don't worry. There we go, just like that, told ya. Again, apologies for my camera, it's been acting up lately. Now we're quickly going to pre-tin these to make it easier to solder onto the transistors. There we go, just like that. Now we're quickly going to solder everything on, just going to pre-tin the collectors of the transistors quickly. Also makes it easier. As you can imagine, I go through a lot of solder. Now let's quickly solder this wire onto the collectors of the transistors. And there we go. Giving me a bit of trouble. There we are. There we go, just like that. Bring that MOSFET straight again, probably use transistor straight. Now we are going to take the 200 ohm resistors. Get my camera to focus again. These are 100 ohm resistors. We're just going to go ahead and solder these onto the bases of the transistors. Just going to pre-tin them again. Makes it so much easier to solder everything on when you pre-tin it. There we go, just like that, onto the first transistor. And then we're quickly going to do the same for the second transistor. Remember, these are getting soldered onto the bases of both transistors. There we go, just like that. Let's have a quick look. As you can see, everything I've been explaining, and that is exactly how it is so far. Now let's start connecting the transformer. We're just going to go ahead and strip the red wire quickly. This will be your positive. This will get directly linked to your battery and your transformer positive as well. We're just going to link it up just like that to the center tap of the transformer. That will be your positive. For now, let's just leave it as such. I ran out of black cable, so I'm using blue cable to represent my negative in this circuit. But it doesn't matter what color cable as long as you get the polarity correct. Just off camera, I'm busy pre-tinning the blue cable. We are going to now solder this blue cable to the two sources of the MOSFETs that we have linked together via the resistor pins that we left long. Just like so. and that point will act as our common ground for the rest of the circuit as well. See there, quick tug test. Cool. Now let's go ahead and grab all our other little parts, our regulator and our fan that has been modified. Move the transformer out the way for now. Now let's quickly prep this regulator. You can see I've already cleaned the wires. If you don't know how to make this regulator, please go and watch my other videos and you will see how to build the regulator, and also the video where I modify this fan. Let's quickly link everything together. So our regulator, the orange wire, is going to output a 5 volts into the fan. And it will also help the frequency coming out of the fan to stay stable as your battery becomes more and more depleted during use. You can see there everything has been connected, just like so. And now the red and black cable going into the regulator will just directly be connected to the negative and positive of the transformer section. You can see that I've got the negative, the blue wire, in my hand, and all I'm going to do is just connect the negative of the regulator straight to that. I find building everything in sections makes it much easier and you don't get confused as often. Now the positive, we are just going to link to the positive of the transformer, just like so. Now we're going to go ahead and take the frequency outputs from the fan, and we're just going to directly link those to the 2 resistors, the 200 ohms resistors that is. While I'm busy prepping these wires, let me explain to you how this works. Because your power coming out of your fan is only going to be within about 5 volts, your MOSFETs will not fully turn on. That's why we are running through these resistors, because the resistors will limit the power going into the transistors, and then the transistors will boost and grab some power from the 12 volt source and send 12 volt into the gates of the MOSFETs as they switch. This is the perfect amount of power to make sure your MOSFETs switch on fully. Now that you can see it's all connected, everything is like it should be, just want to quickly run through how everything works. The 5 volt regulator is going to supply 5 volts to the fan, and then that is going to get power from the positive and negative of the rest of the circuit. When the fan spins, it's going to induce a frequency into those wires, sending that to the transistors and MOSFETs, and thus turning on and driving your MOSFETs. And that's pretty much that, very simple. Now let's quickly solder on the outputs of our transformer, or in this case, since we are feeding power back, they are now going to be the inputs of our transformer. You can see there, I'm just showing you them again. Those we are going to directly connect to the drains of both MOSFETs. Just going to quickly prep them. You can see that I've got my solder. I've already cut them. What I'm going to do is just wrap the solder around the actual cable itself. Because it's quite a thick cable, it will be a bit tricky to solder and prep that and hold it. It's just a neat little trick I've learned. It helps. You can see that I've done both of them. Now let's quickly go ahead and solder that up. You can see that it makes it so much easier to just solder it like that. There you go. Don't worry about the soldering being a little untidy. This is just purely for demonstration purposes. I'm not going to be selling this unit or permanently using it. It's just to show what you can do and that you don't have to break the budget buying some fancy inverter circuit or so. But of course, if I was going to use this for daily use, I would neaten everything up, make it all proper. But that would make the video way too long. So we're going to quickly pre-tin the drains of both MOSFETs. Also going to make it much easier to solder the wires on. I skipped a little bit ahead because I had a bit of a difficulty soldering them on, but as you can see they are soldered onto the drains of the MOSFETs. And now we are pretty much ready to test the circuit. Because the circuit has open wires and everything dangling around, when you power up, please make sure that the wires do not touch. Like I said, this is just for demonstration purposes, but if you are building the circuit as a proper circuit, do it neat, make your solders quite neat, and also make sure the wires don't dangle around and touch everything, because yeah, that can cause problems. Now we are going to go ahead and power everything up, just quickly checking, making sure nothing's touching. You can see the negative and one of the frequency wires was busy touching. Cleared that, everything looks good. Switch on the multimeter and let's power up. Just going to grab my bench power supply quickly. This is just off camera, just a normal 12 volt power supply. You can see the positive and negative. Going to test it with my multimeter. I've got 13 volts coming out, which is perfectly fine. Okay, let's power everything up quickly. Make sure my output wires do not touch anything, because there will be 230 volts coming out of it. As we can see, everything starts up perfectly. Nothing went bang, nothing released magic smoke, and that's a good sign. I have 12.7 volts on input, and I have 229 volts AC coming out. So the circuit is performing properly. Let's quickly check what AC power I have. 25 volts AC going into the transformer. Very happy, everything is looking very good. You can see I'm getting power from the positive of the transformer and just checking one half of the output, and that is around 12 volts, which is perfectly fine. Now let's grab something to switch on. You can see I've got an LED light bulb. This light bulb is rated for 6 watts, 220 to 240 volts in. I'm doing this live, but yeah, I don't recommend you guys doing this, otherwise if you get shocked you'll do an electrician's funny dance, and that's not fun. Now let's grab something that draws a little bit more power. How about this old light bulb? This light bulb is rated for 60 watts. You can't really see the measurements, but it's rated for 60 watts. As you can see, it powers on perfectly. And that is your cheap and easy inverter with hacked parts. I hope you guys have liked this video. Please do subscribe to my channel to see more videos like this.